হুম, এই কোণেতে, এই কোণেতে তুমি আর ও কোণেতে নড়ছে মালটা টুক 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 করে। এদিকে ভিডিও চলছে নাকি? আচ্ছা,
এটা আমি ইউটিউবে দেব।
না তাহলে তোমার মুখ থেকে
কিছু কথা
নিয়ে
বলবো
আসি
কি এটা কি?
এরকম।
এবার এখানে নিয়ে আসো। আবার দেখুন, আবার কমাটা কমে গেছে, আবার ইয়েটা কমে গেছে দেখুন। আবার ওইদিকে দূরে কাছে নিয়ে যাবেন না, তাহলে আবার লাইট টাইট পড়ে যাবে, তখন আবার এই পর্যন্ত থাকবে, এই পর্যন্ত থাকবে।
ব্যাস, এবারে এবারে বন্ধ করো ক্যামেরা।
না না, থাকুক না, আমি দেখবো 10 মিনিট হোক। এই এখন থেমে গেছে, এবার
আস্তে আস্তে থেমে যাবে।
এবার আমাকে দিয়ে দিন, আপনার হাত ধরে গেলে আমাকে দেবেন।
তো এইখানে বসিয়ে দাও না একটা জায়গাতে।
এটা বসানো যাবে না, দাঁড়ান
এইটার তলে একটা, ওইটা দাও আস্তে আস্তে। ওইটা হয় নাকি? এইটা দাও।
এটা তো ভালো করে বসানো যেত।
হ্যাঁ,
দাঁড়ান আরেকটা কিছু দিচ্ছি, বসছে, দাঁড়া আরেকটা কিছু দিতে হবে।
আরেকটা ছোট্ট কিছু লাগবে। ওইটাতে হবে না। আরেকটু উঁচু। হ্যাঁ, এই বইটা দাও, ওইটা সরাও।
রেখে দিয়ে রেখে
পড়ে যাবে কিন্তু, পড়ে যাবে, ওজন পড়ে যাচ্ছে।
আবারও থেমে যাবে,
আবার থেমে যাবে আস্তে করে।
ঠিক আছে থাকুন। আমি হলো আমি গিয়েছিলাম, শুনুন, আমি 5টার সময় গিয়েছিলাম, আধ ঘন্টা হলো, আমার দিন কত থাকে। থেমে গেছে।
এই কতক্ষণ ধরে চলে ভিডিও?
চলবে যে অনেক, যতক্ষণ 1-2 ঘন্টা। ব্যাটারিটা কতটা আছে? অনেকটা আছে, ব্যাটারি অনেকটা আছে, অনেকটা ব্যাটারি আছে, এই এখন 10 ঘন্টা চলবে।
আচ্ছা, এতে আবার দাঁড়িয়ে গেল।
ও গ্রেট।
এই আমি আসছি।
হ্যাঁ
হ্যাঁ, এবং আমি একটা ছবি দিতে বলেছিলাম, নাম নি। এই ভিডিওটা যদি আমার পেন ড্রাইভে তুলে দিতে পারো,
একদম তো ওটা কিছু হবে না, ওটা ফেলে গেছে। সকালে এখানে দেখ, হ্যাঁ পুরো ফিক্সড। রাস্তাটা শুরুতে বলুন না, রাস্তাটা শুরুতে বেশি থাকে, কিন্তু জিনিসটা বুঝতে পারে না। উপর দিকে আপনারা ফ্ল্যাট নেই, ঠিক আছে, কিন্তু ওপর থেকে এই পিছন দিকে উঠে রুটটা, হ্যাঁ শুধু প্রচন্ড এদিকে আমরা
what I have done is that stability is very much important here. The highly non-linear and strongly unstable system. So strongly unstable systems will command it. What we have done here, we have designed lead compensator for this system. And please, and you can see this that the stability is so good here. So control system now plays its game. That's why science is sometimes calls it's a magic. The ball is vibrating and acceleration, because it is acceleration. It is two type force that the coil, the force that is produced by the coil, and the mg that will be balanced with this the force with the coil. It is also the main problem is that the acceleration, that is the m dt by dt2, and this acceleration is the upward direction. That's causes a unstable system, open loop unstable system. And for this open loop unstable system, open loop unstable system, one pole will be the right hand side of the is plane. So what we have done, a lead compensator can compensate. It will work its own work, but in spite of this, we have also designed a RX uh, along with the series with the LDR such that it can also help us to control the base current of the transistor. And so this is, yeah, please see that the ball is fixed. Now ball is fixed, and yeah, no acceleration. I think that we have used LDR, so that's the problem. And the outer uh, the light signals from the outside can hamper a little bit of light, small, uh, it is also invisible to all. That can also make produce a noise here. So it's a very much unstable system, not only for its uh, not only for its mathematical model or the mathematical description, but also we have used a very non-sensitive earlier here. That's also can create a problem. Yeah. So we are trying to use a IR LED. You can see that beside there have another circuit that is also designed by me, and there we are trying to use IR LED and photo transistor. So you can see here, and this is 16 minutes, and not about 16 minutes, but I went to bring this camera that also take 20 minutes, so this is almost 36 minutes till now it is levitating. So you can see that the stability is so good here. You can see the stability is good here, and yeah, please, little bit of vibration is coming, I think so. uh, uh, yeah, we'll have to see this. Okay, still problem is not like that. Oh, okay, then we can go with this way, where we can see this. Now please see that the stability is that, and you can see here. So okay, and so this is a closed loop control, right? This is attraction type levitation. Never when attraction type levitation, never open loop stable is never possible. So it's very interesting since you know that the Japan has done this in bullet train. I think that the magnetic revolution is coming soon in the next generation, right? And wherever there is a frictionless, so always it gives a better result to us. There are no noise or stability. So what I want to say, do you see this now? This is very interesting. It is not vibrating now. It's yeah. This is called the stability. For this highly nonlinear and strongly unstable system, please see this the stability. And our two equilibrium point, I already told that there have been dt by dt2 that is in upward direction, so that causes a negative sign. And also for the mathematical description, you can see this that there have an unstable pole, that unstable pole creates the instability, open loop instability. For repulsion type levitation, it is not a problem because there have been to but that helps that actually helps to become open loop stable. But the aim DT2 was always create a second order system, but the problem is in repulsion type levitations there have the system is open loop stable. And we have analyzed all the force diagram part. Actually, firstly we started in this work. Firstly we started when we started this work. Uh, Firstly, I plotted the force diagram profile. Actually, not force diagram profile. First, you want this coil. So, if you know the mg means the mass of the wall, then you can easily know what will be the approximate force to be levitated. And if you know these, then you can easily design the coil. So first point is that you will have to design the coil properly. How much turns it will be, how much current it will be, and then you will have to um, plot all the plots, current diagram plot. First, current diagram plot. If you know current diagram plot, then you can easily draw the inductance plot. Alright. Uh, in Maxwell also you can do. You can put the value at different point, and give the current to the Maxwell, and you will get the different type of energy distribution plot, and you can from there you can easily get the inductance profile. But if when you get the inductance profile, you can easily choose your operating gap means in which operating point. Actually, this is highly yeah, the inductance plot, you can if you see this inductance plot, then you will see that the inductance is inversely proportional with the air gap. So once you get inductance plot, we will get two things. One is the what will be the operating point, and second, at operating point what will be the inductance. If you get operating point from current diagram plot, you will get the operating current. So you will get and so and going to this now already. And from inductance plot, from Maxwell you can also plot the force area plot, right? So you have got I naught, you have got J naught, you have got L naught, right? And you will have to, from inductance profile, you will have to calculate the capital C, because E equals to C into I by Z squared, right? So C is minus half I square dl by dz. If you get C, capital Z, it's important C, because it will come and 10 to the power something order. It's very much important. And the sensitivity of the LDR, that is per voltage per millimeter, that is also very much important. Yeah, if when you will model your system, then you will see this if the sensitivity is not proper, then your mathematical transfer function will not match. And if the transfer function don't match, if transfer function don't match, then the wall is vibrating again. Okay. Hmm. So then, what I told, yeah, mm, sensitivity is very much important here, and you will model the transfer function. Then it will be a third order system, including electric dynamics and mechanical dynamics. Third order system. One pole will be in the right hand side of the plane that causes is open loop unstable, and what we have designed a lead compensator to compensate, and the transfer function came 21 into s plus 10 by s plus 100. Actually, the pole of the unstable pole comes at is equals to 10, so we have is equals to 14.5. So for the compensator pole we have chosen and is equals to 10. If it is at 0 is taken 10 times of the pole, that is 100. Now the gain comes 21, and we have used BU406, which gain is 16. So 21 by 16, 1.3 or something. That for this we will have to use amplifier. Now our we have used BU406 that acts as a linear amplifier mode. That is in an amplifier mode. In amplifier mode, in amplifier mode, we got that IC is 0.6 ampere. You can see this that IC is that according to calculation IC is 0.6 ampere, but you can see here that IC is not 0.6, it is 0.45 something, right? 0.45 it is now. So 0.45, yeah. And also you can see this, the operating gap is not 60 millimeter. Our operating point was 60 millimeter. So this is the model on dynamics, right? Uh, so also we are trying to use a MOSFET that will try to use it in active saturation resonance pulse WRM. Already we have started this work, and I think we will be successful within few days. Yeah, our confidence level is always high. Yeah, and you know that I mean myself, Janardan Kundu is highly spiritual believer. Yeah, so always I know that everything is possible. Nothing impossible itself says I am possible. Then what we can do? What we can do? And, I don't think it's not possible. Actually, he don't believe himself. Right now, right? He don't believe himself. So, also we'll try. When I went to CSI Delhi, they asked me that within how many days you will take. I told them then 2 years. But my guide told me that after realized that it is too much confidence. Yeah, it was too much confidence. This shouldn't be like this. Science is a magic. I don't know why people go restaurant, shopping malls like this. If they really get pleasure there, I have a question to them. If they are a pleasure is there where there is a silence. Where there is no silence, there cannot be pleasure. I believe this. Wherever there is silence, there must be pleasure, there must be peace. If you go inside a huge crowd, you will never get pleasure. So people laugh. I don't know why they go there. If really they get. I asked the few people if they really get. They told me they become frustrated there. So I asked why you come here. They told me to get peace. So if you get if you be frustrated here, then why you come? So they have no answer at all. Actually, they don't know where they will get the peace. They are searching the peace. Actually, man, actually man, after coming in this world, he always try to search what he needs. Actually, he tried to search what he needs. After finding it, he returns back in his own home. Right? Ball is again privating more. We'll have to see what he do. We'll have to see what he do. For 2 hours spent. Actually, we want to cross the limit. We want to levitate it for 3-4 hours.
Solid gold.